This week we'll pick up where we left off last week by creating some identity access profiles and uploading our figures to S3 using the Boto 3 client. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. If you haven't watched last week's video yet about creating these plots that we're going to upload to S3 and setting up an S3 bucket, you should watch that video first because we're going to pick up and start uploading these images to S3 after creating an Identity Access Manager profile. So finally, now that we have the plots, it's time to try to upload them to S3. I'm going to create a function. I'm going to call it upload figures to S3. And it's going to take the path to the files that I want to upload, the extension of the files that I want to upload, my bucket key, my secret key, and my bucket name. All right, so the first thing that we're going to do is create an instance of the Boto 3 client. So this is a client that connects to Amazon, and then we can call on it things like upload file, delete file, move file, and so on. So I'm going to call that S3, Boto3.client. I want to use the S3 service, the AWS access key ID is going to be equal to our bucket key. The AWS secret access key is going to be equal to our secret key. And that's all we need for the Boto 3 client. All right, so next we're going to find the files we want to upload. And to do this, we're going to use Pathlib's glob feature. So I'm going to create a list of files to upload. On my path to files, wherever these files are, I'm going to call glob, and then use an F string because I want to find any, well, .png would be how we would hard code it, but we want to find any extension. So our user can pass an extension, and we will use this F string to find anything dot that extension in path to files. Now, path to files is going to create an iterable thing, but I'm going to go ahead and turn that into a list. Now, this next bit is a pattern that I've seen with a lot of Amazon Web Services workings. So it is clearly considered best practice. It's not necessarily how I would like to code it, but they use a flag, so let's call it upload success, and set it to be true. And now we're going to try to upload all of our files. Now you could get certainly more sophisticated with this and catch different types of exceptions or record the upload success for each file, but we'll stick with the simple pattern for now. So I'm going to loop, so for file and files to upload. I'm going to try to do the command s3.uploadFile, which takes the file locally, the bucket name, and then what we want to call it or where we want to put it in the bucket. So we need to put a string around file because it won't handle a pathlib object. Then our bucket name, which is getting passed into the function. And then a string around what we want to call it or where we want to put it on S3. Now that file is going to have the path locally. So my plot subdirectory or maybe even somewhere else on my hard drive. I just want to keep the name. So I'm going to call .name, which will be just the name of the file. The stem would be everything before that, and name would be just the actual file name itself. If there is an exception, we will set upload success to be false. And this is what I don't really like, is catching all exceptions. I'd rather catch a specific exception. But for now, like I said, we'll go with this pattern. And finally, after we've done this for all the files, I want to return upload success so we know if our function completed successfully or not, and all the files were uploaded or if there's a problem. So finally, we're ready to call I'm going to assign it to status, our upload figures to S3 function. Notice tab completion there to save some typing. So it takes the path to our files, which is going to be a path object for the directory plots. I want to upload all PNG files, so it'll ignore other things in that directory if there were any, say HTML or JPEG. Our access key, our secret key, and our bucket name. So if we do this and look at status, it's false. And that's going to be because we haven't input our access key, secret key, and bucket name. So I'll show you where to find that, and then you can do it for your bucket. So to get access, we need to go to the Identity and Access Manager, or IAM, and into Users. And we're going to add a user. And this is going to be a program user, not a person. And we're going to create a username. So mine's going to be MetPyMonday. And under access type, we can say programmatic, because we just need that access key ID and secret access key. We don't need a password to log in to the console. This is just a virtual user. It's a program only. Next, we'll go to permissions. And you can create or add them to some groups. So you may or may not have any groups here. I'm going to go up to Attach Existing Policies and search for S3. And I'm going to use the S3 Full Access Policy, which if you click on, it will show you a summary. This means that this user would have access to all of my S3 buckets, which may or may not be what you want. You want to generally use the smallest amount of permission possible to let something happen. So I would probably create a role that just can see this individual bucket. But for this demo, we're going to use the full access. I'm not going to provide any tags. We get to review, and I click Create User. Here you've got the opportunity for your access key and secret access key. You should get them now, as once you leave this page, you will not be able to get them again. You can also download them as CSV. Of course, you can regenerate credentials, but this is the only time you can get this set of credentials. So I'm going to go ahead and copy those over. Now I'm going to fill in the bucket name as MetPyMonday and run that cell. Now let's go back down and try to upload our figures again. Notice now the status is true, so this was a successful upload. Back at our management console, I'm going to go into S3, into my MetPyMonday bucket, and there are my plots. My plots named plot_slope_intercept.png, and I can click on one. I could download it and pull it up, and there's the plot. So I could then share this data with a collaborator. I could use it to display on a website. I could feed it into some other computer that we're doing computations on in the cloud. This is really a good way to get data from your computer that you've generated using a Python script, or even from a server running on Amazon that's been generated, into S3 for long-term storage, sharing, or other operations. I hope that you found this useful, and I'll see you on next week's MetPyMonday.